Hey guys, welcome back. We're now in our third video. We're going to talk about decimals um, again. So I think I've got division working. I haven't tested it all the way, but we're at least on the way to an answer. You may have noticed as well, I've started working on some JSDoc commenting. JSDoc commenting is pretty handy. It should come standard if you have VS Code. It's already there. Um, Normally, you're used to seeing comments like this, or if you do something like this, you can do this for multi-line. And I don't know. Yeah, I guess that does work as a comment. JSDoc commenting is a bit different. You need to put 2 asterisks at the beginning, and then when you click enter, it'll automatically create a new asterisk for each line. And it has these handy dandy little at symbols that you can use for things. So you could put like author, and I could say, here's my name. Usually used for things like the parameters and telling users what the return value is. And then when you do something like this, you can hover over it, throws param and returns. It'll tell you it returns num. And if I put something in like here, return string. Throws error. And then we could say if string is not float. And it would show up right there. So it's kind of handy. Especially if your code base is used by, a lot of different people, this is pretty handy just to be able to hover over it. And then if you look, let's find where I use cleanse string somewhere else. Yeah, so you can hover over it down here. And, especially useful for things like modules that are used as dependencies. That way you can, users of it can hover over it and look at it. So let's take a look at division though. Got a lot of code here that we're going to eventually refactor, presumably. So we've got division it's a bit more complex than multiplication, and multiplication is also more complex than addition and subtraction. With addition and subtraction, what we had were all we got to do is make sure the decimals are of equal length, and we can deal with it after that. With multiplication, we just needed to make sure that we counted up the amount of decimals, because the decimals on multiplication are going to be less than or equal to the sum of the decimal digits of the multiplier and the multiplicand. So if you do 1.25 times 1.25, you're going to get 4 digits. Now, the last digit could be 0. We have ways to handle that, right? We can take off the zeros at the end fairly easily. That happens in both addition and subtraction as well. Division, we can get infinite digits, right? If you divide 1 by 3, you're going to get a series of infinite digits. And so how do we do that? Well, right now what I have is an extra variable here called pres, short for precision. If the user doesn't input it, it sets it to 10 automatically. And then we have a rounding, because we are precision is essentially a rounding feature. And if it's true, it's going to round up. If it's or if it's true, it's going to round up or down depending on the value. If it's false, it's going to truncate. If the user inputs something for precision that is not a number, it will set it to 10 automatically so that we don't run into any problems below. Right now, we are still using parse int in this. We could theoretically wrap everything in a big integer to make it deal with things a little bit more easily. But the reality is I haven't done that. Maybe that'll be done in the future. Because it is possible that someone could want something that's 20 digits long when you add in the decimals. But because of that, the precision, I can't be taking in numbers that are bigger than 15 digits long for division. For multiplication, I don't think I can either. I think it actually has to be less. I think it actually has to be closer to 7 or 8. For addition and subtraction, the numbers can be, all they got to do is be less than 15 or less on both sides of the decimal point, and I'll be good. But if we wrap anything in a big integer, presumably it'll be it can deal with that at much larger scales. With that is going to come a much longer time to compute a lot of these things, I imagine. So let's get started. Let's go a little bit deeper into this. So this is the precision cleansing that I just talked about. As above with multiplication, we're going to take out the negative signs and deal with them later. We may not necessarily need to do that, but it is going to be easier since we're going back between strings and such, and I need to count the digits in various places. So I'm not actually using, I don't think I'm using proxy anymore, and I'll have to look back to make sure. But okay, dividend equals, we're doing our cleansing here, right? We just kind of went over this and showed what it did. And I've done that in previous videos. I think in the first video I had it as code within the function itself. In the last video, I had taken it out and made it its own function because it's getting recycled through each thing, and I thought it'll be easier just to have it as its own thing. If dividend at character at 0 is a negative sign, right? Negative equals the opposite of negative. So it gets set to true, and then we take that out of the string. Same thing here. So if they're both negative, right, a negative divided by a negative is a positive. So this is going to get reset to false. And then if dividend or divisor equals 0, we handle that differently. If dividend is equal to 0, we're going to return 0. If divisor is equal to 0, we're going to throw an error because you cannot divide by 0. We do our M&M. I don't think I'm actually using I'm not using the decimal pointer anymore, but I am using M and N right here. And if I need to, this doesn't actually handle the or compute the index well if there's no value for this. It ends up that a string that's entirely behind the decimal place and with no decimal end up looking basically the same. So I have to account for that here. And then we can take it out. And then we're going to start adding zeros here to handle that. And then once we've done that, we can turn them into numbers. So what are we doing now? This is going to be our return value here. The first thing we are going to do is run a division operation on them. And we don't want to deal with decimals as much as possible. So what do we do? Well, if you remember your long division from grade school, if you want to divide two numbers, say 279 divided by 54, and I don't know what this is going to be yet. Actually, let's make this smaller than 27, just to make it a little bit easier. The first thing that you do is get the value here. You start with these two numbers because this is two numbers long. And then we do this. And then we drop the 9. This is 0. So that's what this first operation is doing right here. Now we have a remainder of 19, which we can, if we wanted to do, get a better value, we would start adding in the decimal place right here. We're getting the remainder right here. We're going to set it to negative now because we're going to start converting it to a string. This needs to be cleaned up, but we can still sort of go over it. If it turns out that we're, if this 26 over here were in fact 280, this would be 0 right now, and we'd have very little to work with. So we need to put in a decimal place. And now we're going to enter a loop where, recall that we've set the dividend equal to the remainder. So we're now running a new operation where 19 divided by 26. It's 0 in this case. But we get that answer. Well, actually, we finish this up. So it's actually, this is 0. So we do 190. So multiply it by 10, 190. We are appending the 26 or 190 divided by 26, which is, I think 7. 26. Yeah, 7. And that ends up 7 times 26, 182. 82. We get a remainder of 8. And we do that here. Then we go through it again, but we're ticking precision down. As long as precision is greater than 0, we're going to keep on doing this. And so what does this do? Now we do another operation. 26 divided by, or 80 divided by 26. That's 3. 872. And then we append the 3. We get a remainder of 2. We multiply that. In the next go around, we multiply that 2 by 10. This next operation is 0. So that 20 state, or that 20 state, or the 2 stays the same after it's multiplied by 10, 20. And then in the next go around, we multiply it by 10 again. 200 divided by 26, 9, which is 8. Actually, I think it's, I think it's still 7. Yeah, it's still 7. So it's 182. And we'll get a remainder of 18, becomes 180, and we keep on doing that. So it turns out that it's actually fairly straightforward. We've just got to figure out how the loops work. This is working right now. It needs to be optimized. But you can see I've got some stuff going on in here, testing. Testing if some other stuff works. Delete this. Go ahead and open an integrated terminal. this stuff too. And there's our answers. So pretty handy. Let's see, 1.5. Yeah, that looks correct. B 1.5 divided by negative 25. That doesn't look right. Oh, actually it does. Yeah, 0.06. 1 point. Should be negative though. It's kind of curious that it's not. Or no, sorry. It's the other one is negative. Yeah, so that's all right. And you can see the precision here doesn't come into play. I believe if I set the precision here, though, it should work. Let's see. Yep, that precision is working. And I think, how long is this? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is what it's supposed to be set at if no one puts in value. You can override that to a max of 15, which is what this is. But it doesn't, like I said before, it doesn't let you go past that. It catches that and resets it. So, bit of a shorter video. I didn't think that. Turns out division is much more straightforward than I thought. But I had been taking me quite a few days to figure it out. But this is basically fully operational now. There needs to be some more testing done. And we need to probably optimize and clean up our code. But this is it. Big things we did were, this hasn't been implemented yet, but it's written out. I need to go through and change it. These are dependencies, or these are dependent. These are dependent upon by all of the operations. I can actually stick these outside of the class, which I think I will end up doing. I just want to make sure when I'm testing it as a require from other from other code bases that it can still be used when it's outside the class. I'm fairly certain that it is, and it'll make it good, or make it better, because users won't be able to access those directly, which I don't want them to be able to do. But this is basically our code. It's all ready to go. I haven't gotten exponents working for decimal values. That is, as it turns out, quite difficult, because a decimal, something like 2 to the 2.5 power, is the equivalent of 2 times 2 times the square root of 2. So how do you deal with something like that? I don't know. That is that's the answer to that. I can deal with it when it's known, like with 0.5, it's the square root of 2. With 0.2, it's the square root of 5. Or yeah, square root of 5, I think. No, sorry, the fifth root of whatever number. Yeah, so with 0.5, 2 to the 0.5, it's the square root of 2. With 2 to the 0.2 power, it's the fifth root of 2. What do you do for the cubed root? 0.333 repeating? How do you want to represent something like that? If we can get square roots working, it might be worth taking a further look. But we got to see if we can get square roots working. And I haven't seen a whole lot of work out there on that. That's a pretty computationally taxing operation, which is why something like the square root of 2 is just a leaf stored as an object in the math object in JavaScript. So anyway, I hope you guys enjoyed this video. I know it was shorter. I think I'm going to start going over linked lists a little bit more in depth. I've got a couple of things that I can talk about there with, inverting the lists and, merging linked lists and stuff like that. So hopefully that'll be of interest to you. Until next time, drop a like, comment, anything you want to see, and I'll see you guys later.